So guys, let's make the portal gun. This set of assets that you see is actually all that we need. Actor component that we will add to our player character. It's the manager to manipulate the portals, the flow of its creation, removing, placement, updating, etc. Actor is our portal. It's actually one actor for both portals, the entrance and the exit. Enumeration, and depending on the value of its enumeration, we will know whether it's entrance or the exit of the portal. And material. I don't use the mesh, I use the decal to visualize the portal in the 3D world. And I guess we will start with the material for our portal. So, default decal, translucent. Next, this one is to create the border around our portal. We subtract from one gradient another smaller one. Multiply by a certain value to make it glow. Glow is the color, it's the attribute, so we will change it also through the blueprint, because entrance and exit should be different. Next thing is the render target. We will create dynamically, so right now all you need is to have the texture attribute, texture parameter. This operation is to, like, depending on the distance between our portal and our character, we need to change the visible area inside the portal. Multiply also by the smaller one, radial gradient, to have the view. Then we add all results. So our border, our portal are combined together. And the bigger one here goes to our opacity. That's all for our material. Next thing is enumeration. Simply none for the first element, it's good practice. Next, entrance and exit. Maybe if you'd like to have some fancy stuff in portals, you can expand this. If we're done with this one, let's talk about portal manager, because it's the first one to appear. As you can see on the event graph, I don't have much. We'll start with, I guess, the main function. As you can see, I have functions for all of my computations. And this big one is actually the main one for creating and managing the portals. So I'll explain everything here, so please listen carefully. Create portal. We need to have the reference for the portal and the type, it's our enumeration. As you can see, reference for our portal is the actor that we should create, the P portal. This one. So create this one and continue with the manager. Then we line trace by channel, and here is another function. It's Pu1, and it's simply for start and end point of our line trace. So I use player camera manager, get from its location and rotation. From camera rotation I use forward vector, multiply by the distance. As you can see, I have two local variables just to look it nicely. So location is stored here, and then result of these computations is added to the local start and stored to local end. So that's how we should len trace from the view of our character. I'd like to say that, as I told you before, it's not the perfect one, but it's pretty nice implementation of the portal gun to start prototyping this. So please follow me. Next thing is break hit result from our line trace. It's by visibility. And another pure function, calculate portal transform. As you can see, we have location, the normal. So location is for our portal location, and normal for the angle that our portal should be aligned to. And output is transformed, so we can store it here, also just to make it look more nicely. This function looks like this. Our normal that we have here, we make rotator from X and Z axis, also store it to the local variable, and then make transform using location that came from the hit result and our local rotation from this one. This one will lead to perfectly aligned on every angle of the surface for our portal alignment. Sorry guys, 2 nights like hell, so that's why I'm a little bit tired and trying to find the proper words for my tutorial. Once done with portal transform, next thing is to check whether we have portal. Because this is function, and we can use the references inside our inputs, just like this. So we don't need to have the line or wire came from the whole beginning. We check whether portal is valid. If it's valid, we need to eliminate it. It's the function inside our portal. I'll show you right now and explain everything. Okay, let's go with the blueprint portal, and this function is called eliminate. Don't do this at the moment, just make the placeholder for this function. This you should add in few minutes. So, like, the idea of eliminate is to clear the follow capture timer. It's the timer of event that is updating the rotation of our capture component, like the view of our portal. And the main idea is to set lifespan of our portal. So if this function is called, we destroy our portal. It means that we should add another one of the same type. And as you can see, depending on the reference, it should come here. As you can see, I have entrance and exit is like 2 different names, but same variable type. And when we will add or call this function, from this one we will have or entrance or exit. So if we have the portal, it's valid, it means that we have the same type. We need to eliminate or destroy the previous one and create another one. If it's not valid, it means that it's the first copy of the portal, and we should spawn our portal actor. We use type, it's our enumeration, which also come from the function, and local transform that we calculate here. Then our spawn actor will be added. We store it to the local portal, it's the local variable. And then, using switch or enumeration, we store our local portal as if it's entrance to the entrance, if it's exit to the exit. So as I told you. Next thing is to store exit and entrance location and rotation. We need entrance location and rotation to manipulate character position in the world when we enter or exit our portal. So, entrance, exit, actor location, actor rotation, store them to their particular variables, rotator and simple vector, and another one, like depending on each of these type, we will always call another function which is called update portal. This function is also made inside our portal manager. Update portal is this one. It checks whether our entrance and our exit are valid, so they exist in the world. If it's so, next thing is to store the render targets from each of our portal. Entrance and exit, as you know, is our portal, and here on the event begin play, I create render target, make sure that the width and height are of the proper ratio, so it means that it should not be square, like 16:9. I'll make it a little bit smaller to save performance. And as you see, once I create it, I store it as the view texture. It's texture render target 2D. So, back to portal manager. So, from entrance, I get the reference and store it for my manager. The same for the exit. Next thing is update portal, but now it's the function that is implemented inside our portal, our actor. So let me show you this function. BP portal, update portal. It has the following inputs: render target, vector, rotation. Let's continue with portal manager. Just make this function, and then when we will go to portal, I'll explain why we do this. So, and as you can see, we do have two calls of the function, but the first call is for the entrance, the second one is for exit, so we update both portals. So for the entrance, we need to update the opposite, like the exit data, for the exit, the entrance data. It's important. So that's for this function, that's for the main function here. Also, I have one more function, which is called get teleport status. As you can see, I have variable here. By default, it's true. It means that if the portal is created, I can teleport. But then, if I have teleported, I should update the status of my teleportation. So this function, get teleport status, will be updated to our actor of portal. Here So create this one also. That's all for the portal manager. Let's continue with our BP portal, and then we talk about some small modifications. So it's simple act, as I said. Let's start with the setup of the components. I have box collision with a specific box extent, so I don't change scale, rotation, anything. I only change the location on the x-axis. So the center of this actor is the attach point to the wall, to the obstacle. So to make this work precisely correct, we need to simply offset the box collision from our wall, so it will be on the precise edge here. So if box extent on x-axis is 10, the location should be also 10. So it should not overlap the wall. It should start from where the wall ends. Inside here I have decal component, and decal should contain, it's like the size of y and z are the same as we have here of our box collision, but on x-axis it should be higher and should contain the wall. Location -10, it simply fits and looks pretty, so that's why I've gone with this stuff. Also make sure that the decal material is set from the beginning. It's our portal, this one. For the box, we need to adjust its collision. Should be query only, custom collision, ignore everything but overlap pawn. And the last one is capture component. It's our render target. Nothing fancy here except the flags. With the flags, you should go and check those elements that should be captured by yourself. But the more elements that you have, the more performance cost it will be. Or you can go with the advanced version. You can use the show only list. But that's not the point of this tutorial, so let's continue. So, event begin play, we create render target. Next thing is to create the material dynamic instance for our decal. And then for our decal, we set view texture to the material, so our material will know which render target to use. Next thing is to, as you can see, here I have a variable of our enumeration. It's editable and exposing spawn. So when I spawn from portal manager here, our actor, I set this variable from our manager to our actor. And once it's created, it checks whether it's entrance or exit. If it's exit, it goes with this color. If it's entrance, with this color. Set vector attribute color for our portal material. It's our decal. So next, on box begin overlap, I check whether it's the first person checked. Then I store it as the reference, and from this actor, I use getComponentBy class and look for Portal Manager, then store it. From this point, let's open our first-person character. Here, on the components, we should add Portal Manager, and I guess let's end with this one and continue with the portal. So I do have another event graph for my portal. It's called portal graph. To add another graph, you should press on the new one. And here I used fire default event. Not sorry. For this one, I've just deselect so it won't trigger fire with the bullets. And on left and right mouse button, I have two different, like the same function but with different calls. Once I have the component attached to my character, I can use its function. So from our portal manager, on left mouse, I use create portal with the type of entrance, and as I told you before, we have entrance and exit variables by default. By default, they are not valid. That's why once we create the first entrance, this function will go. Another entrance will call eliminate, which will destroy our previous one and go with the flow. So that's why for our entrance we check entrance. For our exit, we do call the same function with the exit type and the exit variable for the portal. So if it's the first call, it's not valid. If it's the second call, the previous entrance is stored, so this one will update the function perfectly. That's a neat trick. I hope you understand the idea of it. Also, for the sake of the demo, as you saw, I've added a simple skeletal mesh with its default animation, but I made it on the node C, so it's only captured inside the portal, but from the first person view, I don't see it. Just to show you the idea of how portal works, so you can visually see the model of our character. So, the last thing is our portal actor. So, when we have the portal manager stored, from portal manager, we use a function get to report teleport status. If it can teleport, we continue with the flow. If it's false, we basically can't teleport. Here in this tutorial, I didn't make the whole functionality to check whole conditions. I mean, because we have so simple and so small box here, when we enter and exit, and the delay between our actions is very small, but it's valid. This one check will be quite tough. Sorry, guys. For prototyping, but to make it precisely more advanced, you should have another one, Boolean variable, the one that should say that you have been teleported or not. Then, on most conditions, you should go check and make the logic. So, not to waste your time, simple check whether we can teleport. Get teleport status from our portal manager. Remember this function. That by default it returns false, it returns true, and if it's true, we can teleport, and then we update teleport status, also from our portal manager. And update teleport status is this one that is created on our event graph. The reason for this not to be the function is that I use a simple delay here. In functions, I can't use delay. So if it checks if I am teleported. If it's true, as you can see, the flow, I can teleport. I update that I can't teleport for the period of time. Then, if I can't, here it will update the status to it as it's false. If I can, it will actually wait a little moment and then update it to true. So basically, when we teleport from one, like from point A to point B, point A is set to be false, and then after 0.2 seconds it will be set to true. So then if I want to teleport back, it will work. Then I use set actor location for our actor that we should teleport, and use opposite location. Opposite location can be obtained through the function that we called from the portal manager. Update portal here. This function, as I told you, calls update portal from our BP portal. This one. So here, we need to update, like we need to switch the Steam capture view target from our portals, like, because we are standing in front of the first one, and for instance the second portal is on our right side. We need to switch the render targets on their places. So from right one to our front, from front to our right. So that's how this trick works. So that's why the capture goes to the capture component. Location from our function here goes to opposite location, and the same for rotation. Next thing is to create the timer, update it every 0.2 seconds, and here is the function which is called follow capture. This function is to control the rotation inside our capture, our scene capture. This will go a little bit, forgot the word. Nevertheless, not at this moment, but soon. So once we have these variables stored, we can continue with our event graph. So we need to teleport our actor. So we set actor location with actor to teleport and opposite location. So next we check if teleportation was successful. If it's true, we need to update teleport status. So our previous one can teleport. If it's false, it means that we can't teleport, so we will stay on our previous location in front of our first portal. But if we can teleport, next thing is to adjust velocity. So if we are entering like using the front vector or our side vector, we need to store the direction, not this direct, like I mean the direction should store its forces. So if we enter our portal, like if we are jumping inside, and for instance, teleports are set to be perpendicular. Like if you go front, we should we should come from teleport, storing the proper forces applied to the proper direction. So for this one, we should, from our active teleport, we should get character movement and set its velocity. Because this operation is only on overlap, this will be called once, and another frame it will be overwritten with the proper forces. So that's why this trick is not very cheatable. I mean, in terms of the pipeline, how to adjust variables or attributes from one blueprint to another one. Whew. So, opposite rotation, get forward vector, it's our direction. Then velocity from our frame, because it's also vector, we need to make it to be the float value. So we use vector length and we update it. Next thing is to set control rotation, because first person character doesn't use actor rotation, it uses control rotation. So this one to perform the perfect character view when it's entering or exiting the portal. Like if we are entering with our face towards to the portal and maybe with a little bit angle, like high up and left, like looking like this, we should store it and restore when we are exiting from another portal. Here comes the work with the rotators and the vectors. So, 1 second break. So guys, back to our work with rotators. To make our character remember its proper direction, rotation, etc. when we enter and exiting the portal, from actor to teleport, we get controller and set control rotation. As I told you before, this is only one frame operation. Then the next frame is updated, and this is just to perform the proper set of the of our transform, only for one frame. Next frame will be perfectly fine. So play camera manager, get camera rotation. Next, as you can see, I have local delta rotation. It's a simple rotator. We should create it here. I show you where I store it, but now just perform this type of function and we'll continue. So we store our roll, but from the pitch of our camera we subtract this pitch from our yaw, local delta yaw. We make rotator and store it to our set control rotation. Our pitch is direction when we are looking from bottom to top or from top to bottom. Our yaw from left to the right. Not to make it too hard to describe the mechanics, like if you take a look at these meshes, they all have different transforms, different angles, etc. That means that they all have different forward vectors. Forward vectors, up vectors, right vectors, etc. there are too many conditions to actually perform correctly with applying character rotation to the view of the portal that is on like this wall or this wall or this wall. We should maintain the proper work of the character rotation and direction in the 3D world, and the same result on the scene capture component on our render target. So it should manipulate. It should be sort of like we are looking through the window, and when we enter it, it should stay the same. And because we have different vectors, it's quite hard to maintain it correctly. Also, because we have portals like on the direct view or perpendicular or upside down or like different other variants. We need to know the difference between them in transforms. Like if they are perpendicular, we need to know the difference, how they are set in the worlds relative to our character. So the difference in angles between them on each direction to perform correct operation when we are changing the direction of our character. So simply this one is to maintain the same direction of our character rotation when we are exiting the portal. So if we are going forward toward facing towards to our portal with like up and on the left, we need to like subtract the difference of each portal that we have, so only our view will be stored, something like this. It took me much brain ability to perform this simple trick. So the last thing on our update portal, as I told you, is follow capture. This one. Follow capture do the same trick here, but for the capture component for our render target. We use set world rotation on our capture component, and as we are maintaining the trick with the capture component before our eyes, we have the render target from the opposite portal, so we need to do this kind of operation. It's delta rotator between two portals. So if we manipulate our, like if we change the direction of one portal, the direction of another portal also changes. Its scene capture is also updated relative to the camera where we are looking at. Because I do have this tutorial. I mean, I have this sample project added to the tutorial. If it's hard to you to understand what I'm trying to say, you can like check it yourself and understand the idea by reverse engineering. So sorry guys. So for the follow capture, I store local delta rotation, this one that we use here on the graph. It's get actor rotator. It's the portal that we are actually looking at, and the opposite one, as I told you, we update opposite rotation through our portal manager for this function. For the entrance, we update exit data. For the exit, we update entrance data. So both portals are updated simultaneously. And update portal here. We store one more time, I remind you. We store our the location rotation of our opposite portal in our current portal that we are looking at. So from get active location, we subtract our opposite rotation, but we should, because they can be on the Z, they on Z-axis they are different, so they can be on the one side, on the opposite sides, and on perpendicular. For this one we should subtract minus 180, so they should always in relation to our character look onto it. So two different portals. On one side they are looking to our character. If they are on opposite side, they are looking one to another one. If they are perpendicular, they also should be facing to our character like this. Delta rotator will return the difference between two rotations, and here the same as we have here, but with the plus one. So that means that if we are looking to our portal, the rotation in the portal is similar to our rotation. So if we are looking up, rotation in scene capture in the random target also goes up. Also, we need to add this delta, because if portal is in this angle 45 degrees and we are looking through it, we should see the opposite vector like this one, what he sees, not this vector but this vector. So it's also if we have the portal on the front, on this one, and perpendicular is on the top, if you look here, you should look down from this one, not on this direction, not on this, or if it's on this direction, not see like this. You should store the direction. That's why we add it like this. And eliminate the last one, because update here is ticking every frame. Once we are dead, or the portal is actually don't exist, you need to clear and validate the timer and set lifespan. This one will be called every time we are reopening the same type of the portal. So guys, that's the core of the portal gun, how it works. I guess I will expand it to grab and pick up objects and walk with them through the portals. Maybe with the bullets, but I guess maybe next 2 or 3 weeks, because this one actually drained my brain quite hard. So I hope you understand and like what you've seen. This tutorial, it lacks some elements like how it is said, clipping for the decals, so portals can be overlapped with each other, but the main idea of this tutorial was to show you the work with rotations of the camera of the render targets and the simpleness of to show you the simpleness of how actor can be teleported. So, one more time, subscribe if you like my videos. I do have Patreon if you would like to support me or not, and Discord channel where I can help you if I have some free time. See you soon.